All right, our next speaker is Mikko Nieminen of the Berlin Institute of Health, and he'll be talking about an update on SODAR, the iRODS-powered system for omics data and access retrieval.
Thank you very much. Good day, everybody. I am indeed Mikko Nieminen. I'm a senior software engineer at the Core Unit Bioinformatics, or KUBI as we are known, which is a part of Berlin Institute of Health at Charité. With me so far? Good. Here to give an update on SODAR. I gave a presentation on this in 2019 in the iRODS UGM, but we have done a lot of stuff since then, and I thought it would be nice to show you kind of what we have been up to. So SODAR is basically our system for omics data access and retrieval based on iRODS. I'm going to go through a bit of background, a bit of the kind of design of the SODAR system itself, then go through highlights of new features. We don't have time for everybody, or everything has been several years. Then do a really quick and probably confusing live demo, a bit of the status and ongoing work and conclusions. That's the menu. So starting with the background. So Core Unit Bioinformatics, we provide bioinformatics and data analysis expertise for translational research. My colleague Clemens actually talked a bit already about what kind of data we handle, but basically we do omics projects, which means like genomics, proteomics, metabolomics, transcriptomics, all that stuff, which means high throughput, a lot of files, large data sizes, many measurements, just growing amounts of data for all our projects. But it's not only the data, we also need to handle the study design modeling, like actually somehow tracking all the study from like the donors or patients to the samples, and then what happens after the samples to get to the libraries, and somehow kind of link these together so they make sense and they're easily findable and accessible. And yeah, it's been said many presentations here already in these 2 days, but the old way of having random Excel files saved wherever and hard drives passed on between researchers, yeah, that's not really cutting it anymore in these days. So what we actually need, we need a large-scale centralized storage and archival of raw data. These are the big files, which we have a ton of, and it's all the time coming to be more. We need to maintain some kind of context between study design and these stored files, so we actually can kind of reach the files from the study design and maybe vice versa. Of course, data protection and access control are key because this is sensitive data we are talking about. We want to support the FAIR principles. Again, I don't need to go into that in detail because you have heard it in, I think, 7 presentations so far. It's a very common issue here. And one special need for us is multi-institute collaboration, because BIH is kind of like 2 institutes in one, basically. And we need to have everyone kind of access regardless of what institute they are a part of. So how we try to answer this is SODAR. It's basically this system for managing all your project data in these research projects. You can see a bit about the environment here in the right side diagram. So basically scientists and also their scripts interact with this system. It can kind of, you can put in data from the actual HPC cluster. You can take data out there for more work. You can archive stuff, also linking to public data and kind of third-party tools. We silo things into projects, which governs access and also which data goes where. We provide both the management of the actual metadata and then the files in the large-scale storage, and we link these together so that it all makes sense. And we have a bunch of other tools to kind of help in the data management work, and it's implemented open source. It's Python project based on a Django web server, some Vue.js for client-side stuff, and so on. How does it look for the user? We have a web UI for browser, kind of standard fare for ease of use. We have REST APIs for kind of programmatic access from script and software. We use DAVRODS quite extensively, mostly for kind of HTTP access to iRODS data, and also random file access, which is quite important to many cases for us, because you don't want to download the entire binary alignment map file, which is like several gigabytes of size every time you want to look at in a genome browser. Also, we provide access with existing institute credentials for multiple organizations, which is, again, very important for us. So data is in projects which are organized in categories. If you ever use SharePoint or something, you know what I'm talking about. We assign project-specific roles to users. There are kind of multiple levels. And SODAR also manages iRODS user access. So if you give someone access in the web UI or the REST API or whatever, it also gets immediately done in the side of iRODS. How do we actually handle this? Data management, the workflows goes like this. We have sample sheets which model the study design. For this, we use the commonly used ISOTAB format. Some of you might be familiar with. It's basically, you have an investigation under which you have a study or several studies. A study basically tells how samples are derived from donors or patients. And then under each study, you have one or more assays, which kind of describe what happens to the samples after that and how do we end up with libraries and so on. These are actually node graphs because they can split and pool, but usually the user sees them as kind of Excel style tables for easy editing. The actual large scale study data, I bet you saw this one coming. We stored in iRODS. We link to iRODS from the sample sheets. So for a certain library, you know where to look at. These are the files related to that and so on. SODAR is actually completely file agnostic. You can put whatever you want there. It doesn't tell you, no, this file type is not supported. Most of the stuff is kind of like binary aligned map files, variant call files, what else, quality control files. You can put your cat photos in it, but preferably only if your cat is part of your project somehow. Usually it's not. How do you upload data there? You use landing zones. In kind of our terminology, landing zones is still within iRODS, but it's kind of a separate area where you as a user have a full read-write access. It's related to a certain assay in a certain study in a certain project, and you can do whatever. You can upload, you can edit your files however you want. Then you need to submit them for automated validation and transferring into the actual sample data repository, which is what you see through the sample sheets up there. And that's read-only. You don't get to modify that anymore. That's how we ensure that even years from now, when you go back to your old project for data, it's still there, it's still the same, no one has modified it. And we do some kind of nice Python-based transaction stuff with iRODS so that we, even if there's one error in your transfer, we roll it back and tell you to fix everything and try again. So we don't end up with like a half valid data in the file system. And yeah, this landing zone stuff, it can be manual, it can be a scientist going with iCommands and IRSync to upload files. It can be automated by tools. We have both widely used in our projects. So yeah, let's see how I'm going with time here, but last presentation, 2019. So SODAR was already in use at Kubi, but it was heavily in development. It was used in dozens of projects. That's the most clear figure I could pull up from my presentations back then. And some parts of the source code were made public, but like most of it wasn't. We could import ISOTAB sheets, we could view them, and we could search through them, and we could link through iRODS files, and we could also search for them. So data was nice and findable, but yeah, the editing was not really there yet. We had IGV genome browser integration from the sample sheets, pulling up like iRODS files automatically and creating session files on the fly. And we had a quite limited REST API for some specific, really badly needed functionalities. So yeah, it was kind of working, not quite there yet, but let's highlight some new features. And if you wonder some of these, how do we deal with iRODS at all? Keep in mind, all of this is so that we can find the iRODS files and have some context to the data in there. Now we can actually create our sample sheets from templates straight in the UI. We have a bunch of different templates kind of corresponding primarily to Kubi use cases, but these can be expanded in the future. And we hope to make kind of it easy to just upload your own templates to the system and customize them and do whatever. They are created with Cookie Cutter, which probably some of you know, it's a very common templating tool. We have editing of sample sheets, which actually was a kind of a problem because the existing tools for the ISOTABs were not very user-friendly. And also, even though the files kind of look like Excel tables, they're really not. And if you just edit them with Excel, you can very easily kind of make mistakes which make them non-machine readable and not conforming to the standard anymore. So we started working on an editor, and boy, that has been an effort. That has been quite some work. It's a complicated standard, I have to say. So there's a list of features we have of standard cell editing, of course. We can restrict columns to a specific format. So if someone else comes and fills out the data, you can make sure that they don't make mistakes, that at least everything is in range or corresponding to a specific regex or a list of options or something like that. We can insert and delete new rows in study and assay tables. We have a quite nice ontology term lookup. I will be talking a bit more about that in a second. We save versions of these sheets, so you can compare versions and restore them and also export them as ISATabs as you wish. At any point of editing, we maintain full ISATab compatibility, so what you export will be 100% working and parsable by other tools. This is not trivial, actually. And this is not a 100% feature complete editor. You cannot do everything, but what you can do actually works. And that's already something, but we're working on it. Something about the ontology term lookup, we wanted to have this kind of a thing where you wouldn't rely on a bunch of APIs which might be reachable or not, or might be slow or fast or not. So you can actually import a whole bunch of common ontologies into your SODAR instance and query via local API in the UI to get fast response and find those terms to actually annotate your samples or your sources. There are some examples of what we support, basically pretty much everything in the OBO format and then some others which are in different format. But you can also just add manual terms if you want to, or if you don't want to import your ontologies, that's also fine. And we support multiple ontologies and terms per cell, which is kind of our extension to the ISATab, so to speak. We also have pretty much a full REST API now. I wouldn't say every single feature necessarily supported by all important ones are, and you can actually just do scripts and tools which automate anything from project creation and access control to like importing sample sheets to managing landing zones. So you can actually automate those file uploads to iRODS really easily now. And it still goes through all the validation and just like if you would do it manually in a command line. And you can generate access tokens to nicely be able to access this from software without compromising any passwords. So you were waiting for iRODS features, and I got you covered there. We have some ticket-based access control, mostly for external tools which don't want to provide you a login screen to access your files. So we can actually, for certain software, we can generate anonymous ticket to access iRODS. We now use it mainly for the UCSC genome viewer, but we intend to kind of expand this in the future to kind of more general use cases, because we also have some visualization tools which kind of would want to grab data from HTTP, and these usually are then accessed to iRODS for obvious reasons. Also, we have file deletion requests, because I mentioned earlier that yeah, the sample data is read-only, but people still make mistakes, and often you have like, oh, I uploaded the wrong file or wrong version of file or something, and you can request like a project user with sufficient permissions to, how about you delete it from iRODS. Before you had to ask like an admin or person with admin access to do that manually in iRODS, and usually that was me, and this has made my work kind of more bearable because I don't have to do it all the time. And we plan on kind of expanding this in the future as well to ask for moving or renaming files, and then the owner or the delegate of the owner can kind of decide for a project that yes, that might actually be doable. Some other stuff, we realized that there are some environments where you might not have like external existing like authentication system, like we use our multiple LDAP servers from our institutes. So we also have a feature to just create local users in SODAR and then do a custom PAM authentication with iRODS to gain access, so you don't have to manually add users. So yeah, it's a custom Python PAM module. Some admin tools for locating files which do not correspond to study data and then cannot be found by search or found by the UI, because sometimes this happens. Sometimes files get misplaced. And a bunch of command line tooling, because now we have the nice REST API. We have tools for kind of, let's say, if you have a standardized case of ingesting specific files with specific names in the specific places, we have nice tools for that, and the user can just run that and get it over with. Doesn't have to do a lot of iCommands magic to do that. And yeah, also a lot of this utilizes the iRODS Python client and of course the SODAR REST API. Right, that was kind of the highlights, and I'm going to do a really quick live demo and hope this isn't too confusing. I still have a bit of time. So this is completely local. Is this large enough? Can you people in the back see this? No, it's a bit larger. Is this fine? It's fine. Okay. Yeah, just gonna show. This is a list of test projects on my laptop. This is completely offline. And I created this dummy UGM demo project, which has nothing in it except a hello world message. And we go to sample sheets and there's nothing there, but we can create one. Let's do the generic template. That's a simple one. And I think most of these default values are fine, except this one. I don't want this one. I want something more. I want to create a bit few more of these sources and samples. Yeah, this is, there's a lot, but we don't really have to go through that. We can just create something. And now we have a sample sheet there. And we can show a few more columns. By default, we only show those which have data in it. But yeah, I have to move this. I have to move this Zoom window here. Sorry, because it's actually blocking some of my UI. I didn't see this one coming. So let's say we want to edit something. All right, let's say we allow editing of the batch. I'm as project owner now, so I can kind of customize how we do stuff. So yeah, let's say that batch 1 is all we have in this. So but it will always be batch 1. Organism, yeah, we can make this editable, and we can say that it's only the NCIB taxonomy which we allow to use. Also we can say that all of these samples will be Homo sapiens, so we can copy this and add this as a default value. There, now it's going to be Homo sapiens data. Stuff like this. Let's make HPO terms editable as well, and let's set the default suffix for the name of samples derived. So when we create a new row, it's going to be pre-filled. Things like this. Let's just add a row. There we go. That gets pre-filled. And if you're getting a headache from watching my fast presentation, I totally sympathize with you, and let's mark that down here. And yeah, there we have a new row. I could show you a lot more, but I think you get the general idea. You could do the same thing for the assay tables, with the exception that we only start from the sample, because the sources and everything up to that comes from the study table. As if anyone's worked with ISATab, they know. Let's say we finish editing, we are good with it. We can go and see the versions here. Like, yeah, this latest one is good, but we can compare them. Just pretty basic stuff, really, but it's also like it's kind of usable. And at this point, I could say, let's do iRODS. Let's create iRODS directories. Let's create a landing zone. Let's upload some files in iCommands. Don't worry, I'm not gonna bore you with that. You've all seen iCommands, you know how it works. But basically now we have a landing zone and we could do it. A few very quick things. I will instead go to another project which has some data in it. This is public data from the 1000 Genomes project. Not much of it because this is my laptop, but I added a bunch. We can see a difference here. We actually have some links. This shows some files in iRODS. Here are the deletion requests I was talking about. We can say, I don't want that. I don't want that either. No, these things have to go. But they're not gone yet. As an owner, which I am right now, you can go to the delete requests and you can either approve or reject them. I said, no, I'm not going to delete that. That one, sure. And then we get a confirmation that, are you really, really, really sure you delete this, because that will not be undone anymore. Things like this, hardly rocket science, but actually very usable for our users. And access tickets, well, that's kind of, if you ever use iRODS access tickets, it's just a UI for that. Right now, it's limited to very certain collections, but like I said, we intend to expand this in the future. All right, that was some of the kind of quick things I wanted to show. A couple of slides to go, and I'm a bit over, but I don't have much. Status, still developing, but we've kind of been using it for years now. We have 350 terabytes of data, and not the world record, but it's starting to be sizable and it's growing all the time. About 300 projects and about 300 users, and it's kind of now a basic building block in our data management for several years now. If you want to take a look, everything is open source at github.com/bihealth. There are many of related projects, but I think the most important, interesting ones are SODAR server, which is the main web server you just saw, and SODAR Docker Compose, which is a Docker Compose environment for kind of running everything you need to get this thing going for evaluation or development, or even deploying in production. A lot of ongoing work. I talked something about this before. We have a publication on the way finally. We will launch a publicly available demo server on the actual internet. Yeah, a lot of these features I talked about already, building towards a more feature complete sample sheet editor, better iRODS access, more kind of command line tooling and things like this, and upgrading to iRODS 4.3. We are still at 4.2. So yeah, that's kind of almost it. We've continued our work. It's like no longer a kind of a prototype. It's kind of integral part of our work. We've done improvements. We've released everything publicly, so you can have a go if you're interested in something like this in your organization. iRODS has been a super good tool for us since the beginning. Nice support from iRODS developers. Also, DAVRODS developers deserve extra credit because we use that a lot. We become consortium member, and one thing I failed to mention in the slides, the community is of course awesome. And some acknowledgements here, but I can leave it here. You can read them, and I don't think we have time for questions. I did my best, but I went 30 seconds over. Sorry.